Yeah, last time we got through a bunch of different, we finished with asthmas, but we talked about all these different controlling points of a legal description. And we decided to stop right before we get here to some of these figures and some of the more unique situations. And I guess before we jump into it here, let's jump into these descriptions that Joe shared. Um, this first one is one we actually talked about last time, interior angles. And I think that most everyone hadn't really seen an interior angle one. And so here's a great example of that. There's some other oddities with this, but line number 2, in a
Oh, yeah, what is
northeasterly
this?
in a northeasterly direction and forming an interior angle of 112 degrees, 39 minutes, 3 seconds, with the northeasterly line of East Atlantic Avenue going a distance of 216 feet. This is kind of an interesting one because there's quite a few as we read through here if we were to critique it, right? I'm assuming there must be some sort of map that goes with this, or at least some familiarity with the area, because call number 1 just says in a northeasterly direction along the northeasterly line of East Atlantic Avenue. So, if I, who's not familiar with New Jersey or this area, would have no way of starting or calculating this out. And Joe even throws out there the first course should be northwesterly even.
Yeah.
So, but not only is it written weird, it's written wrong.
Yeah, yeah. I'm used to looking at these like this. It's common around here, especially in Camden County where this one's pulled from. So just looking at it, I was reading along with you. I was like, hold on, something's wrong with this one because you can't go northeasterly, then southeasterly, southwesterly. So I was like, something's wrong. So my first thought was it's probably the first course is wrong, northwesterly. So you gotta really take these things and read them line by line and scratch your head as you go.
Yeah. So is there like record maps or city maps, county maps that then kind of line out what the angle is of what the bearing is of like East Atlantic Avenue? So that's kind of a known quantity for people.
Well, this one doesn't call out a filed map, so most likely you're looking at the tax map, assessor's map of the property, and just basing it off of the north arrow off of that. And like I said, it's a lot of times it's head scratching and just trying to figure it out as you go.
Okay.
But yeah, like I said, this one I'm looking through it doesn't call out any file maps. Now, Camden County, you can't get the file maps online. You have to actually go to the courthouse and get the old physical copy of it. So even if it did call a file map, we'd be taking a trip to the county office.
Okay.
So
There are some things I see in here that I actually kind of like. You've got this description of it, but then you get into the south half, some of these qualifying calls being lots 1 and 201, being assessed as lot 201, block 59, being premises number 499, East Atlantic Avenue, being block 59, lot 2.01, being the same land and premises which became vested in this name, with some information there. I did see a lot of that type of stuff when I was in Ohio, especially when they were calling out who owned it, who it was vested in. But there's some good information in there, not just the description, but some clarifying stuff. If there is ambiguities in the description, at least there's some history there, some other things to kind of to point it to. Certainly that description is not an easy one, someone that's not familiar with that area. And we'll read this other one, non-radial lines deed. I didn't get a chance to look through this one as closely. So beginning at a point on the southeasterly curved line of Kendall Boulevard, 60 feet wide, a distance of 406.22 feet eastwardly from a point in the easterly line of Ridgeway Avenue, bounded and described as follows. Eastwardly along the curved southerly line of Kendall Boulevard, curving to the right on a radius of 660 feet. An arc distance of 100, and then a bearing and distance south 70117 west along the division line between lot 30 and 31 distance of 140 feet to a point and corner that's westwardly along the division line between lot 3176 block, said block curving to the left, radius of that. And then it's north 159.35 seconds west along the division line between lot 31 and 32, block going distance 140 feet to the point and place of beginning. So this is kind of an interesting one. There's some good in there that the qualifying calls really are that second half. You know, if you've got a map that accurately describes what these lots are, you know, your any errors or confusions or ambiguities in distances or bearings are clarified by a call to lots, right? And again, assuming there's some sort of subdivision plat or lot map out there that kind of clarifies that. But definitely another odd one for us out west, you know, that aren't used to, you know, meets and bounds states where our meets and bounds go around section corners and ties and are usually just a little bit more, I'll say simpler to follow. I don't know if that's the right term, but simpler for us to follow since we're used to it.
Yeah, it would be great if this deed, I just pulled it up and looked at the rest of the pages, but this deed doesn't call to a file map. And now, let me just clarify, I'm not a licensed land surveyor. I'm just the party chief for my company. I'm just here for, you know, trying to learn more as I go through my education. But I'm out here in the field and you got a deed that has non-radial lines and two curves. This thing's floating all over the place in my mind. It's not until you locate all the physical evidence, everything until you can really hone in and actually start looking for the, you know, the true control that you're trying to get. So like I said, this one doesn't call to a filed map, and you can't really base your, we all know you can't base it off a assessor's map. So and this deed doesn't say which line is radial and which line isn't radial, so you're scratching your head, and you know, and you're pulling every deed in the block trying to figure these deeds, the stuff out. So it'd be really nice if whoever wrote this put in there radial or non-radial. That would make things a lot simpler down the road.
And
Absolutely.
Joe,
And we
it
could
looks
even,
like New Jersey, that NJSA, is that their tax map is what they're referencing? It's not a recorded survey map, correct?
Yes, that's correct. That's just a tax assessor's map.
I like the left and right on the curves.
Yeah,
Haven't seen that for quite a while.
that's the only way we know how to do it.
Wow.
We still write them that way, even today.
Really?
Yeah, for our stuff, curving to the right, concaving southerly or southeasterly or whatever. Yeah.
And they do that in Minnesota too. When we always write out degrees, minutes, seconds. It wasn't until I came to California that everybody just forgets about all those things.
Yeah. So we don't do concave out here. I rarely ever
Okay.
see that, if ever. It's
Yeah.
always just curve to the right, curve to the left. The
Nope,
company
we
I
do the
work for now,
concave.
we give a lot of information. We give out the delta angle, the chord bearing and distance.
So we don't
and-
do chords. We don't do chords, but we'll say the concave. So yeah.
Yeah, we'll do concave.
Yeah.
And we'll do even, you know, center bears, bearing to the center. But it's pretty rare to see a concave call anymore out here.
It helps create that visual though. That's the cool part.
Yep.
So jumping into the book now is kind of these controlling calls, and we'll even talk about some of these in a little bit. But this first big section here is the apostrophe ly parts of an area, the old lee parts, the northerly, northeasterly. And again, that's something I noticed in, was that first one, westwardly.
Yeah.
That's
wordly.
eastwardly, westwardly is
Hmm.
easterly, westerly, wordly.
Yeah.
One we don't see.
Right. Can you Try to zoom in on your screen just
Yeah.
because what happens is interesting. It's like it shows the whole box, like the whole like Adobe.
It's showing my Adobe. Yeah, I'm not sure because I'm using Bluebeam. I don't know how to do like a full screen in this.
Oh, okay.
Maybe that's why. Yeah, I'm not sure.
Let me. You want to stop sharing, and then I can
Yeah.
see if I can see what if mine looks any different. Let's see. Does that look different to you guys? Is that better, or because it showed like your Adobe file, but I noticed it even earlier today when I was doing some share screen stuff.
It's bigger. Yeah.
Okay.
Yeah, it's
okay.
bigger.
Okay. Cool. All right.
Okay, that works for me.
Okay. So we were on kind of 410. So.
410 really, yes, is kind of where this parts of an area. So this is the hardest thing to kind of get through. You know, if we want to do the roundtable discussion like we have been, this is a lot of figures, and he kind of goes through how and why some of these don't work. And if we go to the top, the north, the top of page 411 here, he has half a compass here, and he's trying to explain to us how we decide. Well, is it northwesterly, or is it westerly, or is it southwesterly, and where do these determinations kind of come from? And he's oddly specific in it, and I've never given it that much thought, but you know, it makes sense what he's coming from. I guess as a general rule, I've kind of followed what he's got here.
Yeah, I guess that would be interesting because like you got basically almost 45-degree angle that could be construed as westerly or westwardly, depending on the part of the country. But I mean, that's a pretty big spread where you would think westerly would only be, you know, maybe plus or minus a few degrees, you would think, I guess. But I'm with you, that's pretty big spread. And then southwesterly, you would think would be more at a 45-ish angle, but I guess, I mean, those are some pretty big spreads.
Yeah, I think what he's trying to show is we're talking about an area of a shape, right? Not necessarily the direction of a line.
Right.
And so if you did have a figure and you're trying to show, you know, the westerly portion of the figure, well, you are probably going to cover more of those, that area, right? That angular area coming off of a vantage point or something. So his first one right here is, you know, right under figure 7, when such a direction is applied to the segregation of an area in the expression the north or northerly 50 feet of lot 6, it means that from the south line of that 50 feet is parallel with and measured from the north line of that lot, as in figure 8 herewith. The east or easterly 100 feet of a lot is an area bounded by a line parallel with the east line of the lot and set at 100 feet west, measured at right angles from the east line of the lot. So it is kind of hard seeing that copy, but you can see where he's got the 100 and he's got the kind of the demarking line there of the, you know, 100 feet. And then so he goes through a whole bunch of figures here and kind of walks us through irregular shapes and what it might mean to describe an area of a shape. And I guess I'll throw the question out here. You know, he's given all these examples, but unless we're reading an older deed, how often are you guys finding some sort of area description?
I bet you East Coast it happens every day, right?
Rarely out here.
Yeah, definitely
California.
out in the West, it's not. Maybe some of the old, you know, ranchos or
Some of
something
the
like that.
old stuff. Yeah.
Yeah.
Even that it's almost more like an aliquot part area.
Exactly.
Right, a portion of the east half of the section, right, the east 100 feet of a section or something like that.
And then the flip side, you probably talk to Joe and he sees it every day.
Yep. Yeah, maybe.
No, I don't see deeds accepting out easterly or westerly that often. Be honest with you, that was kind of described to me as a big no-no because of too many ambiguities and figuring out which way is which.
Yeah.
and what do they really mean? So it's usually an exception with a meets and bounds description describing the senior parcel. So
Nice.
I see a number of deeds that sometimes the acreage was the only thing that you could depend on.
Yeah.
And especially if the deed was one that had originated back in the 20s or 30s and then been used in successive descriptions or sales of the property. So it's something that I had to deal with on a regular basis.
Okay, so James has seen it down in the south there. It is, you know, I guess I'm glad to hear that we don't see it or use it a lot. You know, like Joe said, this opens you up to a lot of ambiguity or questions, especially with irregular shapes or irregular parcels, because we don't get clean parcels very often, and so this is up to a lot of interpretation. This figure 12 and 13, you know, these his offset lines, tangent lines he's got in there, or radial lines, are kind of hard to see in these figures in this in the PDF. But if you do have the book in front of you, you can see it. So he's just given some examples of how you might interpret or offset an area call to be consistent. And I didn't plan on spending a whole much time going through this, just because I kind of felt and was hoping that, you know, we're not seeing these very often and need to go into nitty gritties unless people had examples of it. But if we jump to the bottom of page 415, he does have just an interesting one here. He talks about a stair step in figure 17. So with the stair step parcels in figure 17, the easterly or east so many feet of lot is indeterminate, because the statement could apply to either the north or the south portion. The southerly portion can be described as the most easterly feet of the lot. The northerly portion could be better described as the easterly X feet of the northerly portion of the lot, you know, or is it some combination of that, you know, and I think if I were to read that, if it was the easterly portion, if it didn't cut into that north area, I would just hold it as a southerly portion, you know. But if the feet offset was far enough, you know, that's a distance offset versus an area offset. But you know, I could see how it could be misinterpreted if you didn't know what the intent was or the local standard was for a parcel like this. Again, kind of a rare example, and we don't see very often, but certainly something we might want to be aware of.
And I think that's where that, you know, easterly 150 of the southerly 330 or something comes into play at that point, right? Where you're calling, double calling. So.
Double call's great, yeah.
Yep.
And then jumping on to figure 18 here.
And a lot of these, you know, that's a lot of these are on the FS or even the PS exam. A lot of these kind of construed parcels for exam purposes. So it's good to, it's good to definitely read through a lot of this from an exam standpoint.
Absolutely. You know, so he says here under got it in my book here, so I'm going to look down here. Under figure A18, it says the format used for the easterly portion shown in figure 8 cannot be used to describe the westerly portion as shown in figure 19, because the easterly line would have to be parallel with the westerly line and using the remaining distance of 70 feet. It would encroach into the east 100 feet of the lot. This is so whether you use the west 70 feet or the west 70 feet measured along the north line, if you use some lesser distance, it would leave a gap.
That's messy.
It is. Nice. The really interesting thing for me to this is again, not having used these, I might have missed some sort of call here. I would have assumed, you know, a parallel to that cross 70 feet versus, you know, parallel to the west line versus 70 feet along the north line.
Mm-hmm.
You know. just not thinking about it that way, usually doing some sort of perpendicular offset. And so, you could misconstrue something really easily. So that's really the biggest thing I've pulled out of some of these examples.
So is figure 8 a typo or?
I think figure 8's a typo. It should have been 18.
18, yeah.
Yeah. So the next kind of highlighted area, I guess we'll just go through this kind of like as a class, because there's not too much to discuss here unless anyone has examples. But the next one I kind of highlighted was figure 24, the next set of pages over here. He says, so far, these examples have dealt with one part of a parcel using single direction and distance. It is possible to expand this formula into multiple parts using 2 directions and 2 distances, 3 directions and 3 distances, 4 directions and 4 distances, etc. So he gives some examples of these. And I did actually, now that I think about it, I wish I would have connected the dots. It just connected in my head that I did just deal with an easement that covered the westerly 25 feet of the southerly 150 feet of a parcel. It was a square parcel, so it was a pretty easy one to figure out. But I just connecting the dots in my head here. Otherwise, I could have brought up an example of one I've actually used. But that was a square parcel. It's fairly simple to extract out what the westerly 20 feet or whatever it was of the southerly 150. But we can look at different ways of calling out. This figure 26 is definitely a unique one. Example of a triple call is shown in figure 26, where a 30 by 60 piece is taken out of the lot after a 20-foot widening of the street. Thus, the south 30 feet of the east 60 feet of the west 80 feet of the lot in the city of, that description works. But again, I don't know how often we see these or would ever write anything like this, but they're out there, and like Trent said, that would be good for any exam purposes. So
they're definitely out there. I mean,
yeah.
I've seen plenty of them over the years, but yeah, they're all older. A lot of the older easements were written that way, and recently we see a lot fewer of these, and we've gone to more of the meets and bounds descriptions and cut out some of the problems.
Yep.
But yeah, a lot of the old ones, you got to be able to watch for these. They're out there.
Yep. Okay. Any other questions about the portions? I'm going to call them portions of a figure, portions of a parcel, because now we're going to get the one I think we're going to get into some arguments here, and I'm really excited for it. I think it's already started here a little bit when we're talking about convex, concave calls and all that. So his next section on the next page is curves in surveys and descriptions.
There you go.
People have thoughts and feelings about it, and some of them are wrong. All of them are acceptable. But curves become a difficult one, because the thing I try and teach, I've got some younger surveyors that are working under me, and they'll take a description, and it's really easy to, in AutoCAD, just sit here and punch bearings and distances, right? And you go through a curve, and it gives you a core distance, bearing and distance, and it's easy just to keep punching those distances in. But the challenge we have in the modern society versus maybe when this book was written, or those more experienced surveyors, is AutoCAD likes to force things to fit sometimes, despite what you put in there, particularly on curves. And so if you're just punching in core bearings and distances and then trying to create this arc that fits it, far too often I've seen things bust when you try and create a parcel or a description off of something that's been drafted in that manner. But there was a time where we were manually drafting everything, and so it was easier, or more consistent to write things or calculate things in different ways, because we understood the math behind it. And we don't understand the math behind it today. It's just their bearings and distances on a piece of paper, and this this figure 28 right here is a perfect example of what we don't understand. And I'll be the first to admit, being a younger surveyor, is, you know, you get me into the delta fours or some of the older ways of staking and calculating curves in the field, right? That's beyond me. I've never had to do it, but certainly from a description standpoint, I get the nuances and the difficulties of working in an AutoCAD program to try and recreate older deeds and descriptions, and then writing new ones as well. You know, so, you know, quick crash course in CAD at how I recommend doing it, or how I do it myself, is I always go, if given, I will draft my line, and then draft a line to the center of the arc, right? And then create a circle on that, and create my radius based off of the center of the arc, and then come back the other direction and create my tangent line. And then of course I go back and do all the checks to make sure that it's all connected correctly and AutoCAD's done it. But far too often I've seen mistakes made where we just go hitting the point of curvature, chord bearing distance over, and then coming back. And there's a number of different ways to create arcs in CAD, different buttons to do it, and where it's forcing an arc to fit two endpoints. And coordinate wise, mathematical wise, it all should be the same, but it's a nuance of CAD that it busts sometime. Am I the only one that experienced that, or any thoughts on the best way to draft these and recreate them before we get into writing them?
The old coordinate geometry programs, you didn't have this much problem with arcs. You were forced to calculate your BC, then your radius point, and then your EC, and it automatically took care of the calculating of the arc for you. And then you're exactly right, Trent. I see the same problem with AutoCAD. Once we jumped into AutoCAD, then you had to be more exact. You had to make sure that those radial lines were perpendicular to the tangent line to make your arc come out correctly, or otherwise your radial bearings would be out of whack, or you wouldn't be exactly tangent at both ends.
Yep. The other problem I see, and this is my the gospel according to Trent here, is polylines. Anytime I'm drafting, I'm always using polylines. If you're doing any offsets, you know, those BCs, PCs, ECs, whatever you want to call them, PTs, they get offset properly, right? As you try and creating a center line and then creating the right of way off of that, and the arcs and calls that go with that. You know, we've got designers that I work with. I've got an older surveyor that I work with that is everything's a line. It's all separate. And I hate that too, because I don't have to make any adjustments to the piece as a whole. I've got to make sure I grab every little segment. But the other thing that happens is in recreating right-of-ways, you draw on your center line, you take your offset to that to create an accurate center line. But if they're not perfectly tangent or perfectly drafted, AutoCAD creates these gaps or overlaps in those endpoints. And they're easy to get missed when you start writing descriptions or trying to snap stuff on your map to create your distance calls or annotations on there. And so that's just another thing, according to me, is everything should be a polyline. So let's go through here. We've got the parts of a curve, the radius, you know, and just for definition's sake, radius is the line between the center of the circle and its circumference. The length of the arc is the distance along the curve. The central angle or delta angle is the angle subtended by the radii. And we can see that with the delta symbol there in the middle, right there at the angle point, center of circle area there. The semitangent is generally just called tangent, is the extension of the straight line, sometimes called the tangent line, which precedes or follows the curve to its intersection with other semitangents. That's one that I see called out occasionally, is curves called out only by tangent distance. They can be difficult to recreate, if not impossible. And so that's a unique one. I don't know if that's a Utah thing, but I see that on occasion, about 2 or 3 times a year. Curves called out solely by tangents. The chord distance. The chord is that segment of a straight line which intersected by 2 points on a curve, or in other words, the straight line distance between the 2 ends of a segment of an arc. And so they go through the application here. And then there's different types of curves. A simple curve is a single segment arc. That's going to be probably your most standard description curve. Compound curve are groups of 2 or more segments of arcs having different lengths of radii on the same side of the curves, common radial lines and common tangents. Or a spiral curve. Spiral curve is a collective group of multiple compound curves having a radii of successfully decreasing or increasing lengths. Your most likely place to see a spiral curve is in railroads and some highway maps. Some highway departments did use those from time to time. And so you'll see them there. I don't know, Trent, have you ever done spiral curve class in Mentoring Mondays? There's a whole 4-hour class on parts and that, and I've done them just enough to know how to screw it up, and I'll leave it at that.
Yeah, no, I wish we could find somebody who would actually be able to talk about it, because even from a CAD drafting standpoint, it's a pain in the rear. So
Yeah.
we've talked about that a few times on here, but in the chat really quick, in Ohio, you have to describe 6 elements of a curve per Ohio Administrative Code. So there you go.
Okay.
That's 6 is a lot. Holy moly.
6 is a lot.
Yeah. Because
Wow.
we're showing 5 right there with radius,
Brent.
length, central angle, semi, and chord. But yeah, go for it, Joey.
Yeah, so I've got a question about that, because sometimes it comes up where, sorry, I don't know what's been going on with my camera recently. I'm back there on a sailboat. How's that sound? Sometimes I'm checking these or working with a utility on something over a city parcel. They're doing an easement, and they do give like a lot of information on the curve, but sometimes stuff doesn't match. So how do you kind of deal with that as you go forward? Am I holding the radius? Am I holding the tangent? You know what I mean? I think there's kind of a general idea from some surveyors, but I'd love to hear from others what you do when curve data doesn't match.
I think it's length and radius hold primarily. I guess that would be my way of kind of a reconstruction standpoint, but yeah, I guess that's a David question too, from a reviewer standpoint. I
would definitely say radius and delta are the ones that I would start with, at least.
Yeah.
To see how the other pieces fit with what else is going on with it.
Yeah.
I'd agree with that. The only other thing I might kind of caveat that with is there might be situations where I might hold one over the other, and so going through other checks, drafting it, instead of going from the point of beginning around, go from the point of beginning backwards, right? And see if you end up in the same spot, and to see if there's any interpretation there that might be able to be made, or if there's any other adjacent deeds that follow that same curve, and see if someone holds something more consistently, or something matches better.
Yep.
Awesome. Thank you all. Great.
And then Joe also threw in the chat, one of those deeds that he sent you had a spiral associated with it.
And we'll pull that one up next time and look through it there. We'll save those 2 for next time. So
it's a little bit hard for me to get excited about these curves because I have never seen a land dispute that was litigated where a curve description was a material element in what happened in the litigation. Now, that's not to say that everybody ought to do a good job of describing the curves, but it just doesn't seem to be a problem.
That's a
I
great
don't
point.
know how I don't know how to explain it otherwise.
No.
That you just don't run into a case where that's going to be a problem. It never was for me, and I dealt with a lot of really badly described curves, but usually when you go out there, that you find that possession or some other element defines the intent of what the grantors and what the grantees were satisfied when they went onto the property and took up, and really the actions of the owners promptly after a sale can be very instructive as to the intent of the parties as to what was to be done out there. And that plays into a curve analysis that I've been on, but nobody ever really seems to argue about the curves. So maybe that'll make you feel better if you have to deal with one of those that's a real old bear that nothing seems to fit, you know. That'd be my recommendation. Look at the intent of the deeds and what the property owners have done.
Those are great points.
Absolutely. You know, I can think of 2 cases where I don't think it would have ever gone to litigation, but I definitely sweat a little bit when I was going over the descriptions. There was a railroad right of way in Iowa, you know, and the deed called along a portion of an overall spiral curve, right? And so, you know, again, I'm not sure it would. Proper calls in the deeds, we called to the railroad right of way and everything like that. But the math of it that we wanted to have in there is, you know, I had to do my crash course again on spiral curves so that I could make sure I could describe the portion of the spiral curve that we were actually butting up against as we split a piece of the property off. You know, again, there's other calls in there. We called to the railroad right away. We were very specific to be careful in that, but there are times where, you know, some caution is there. You just want to be careful to get it right. But I agree with James. I've never seen one either. You know, they're usually bigger ticket items that get us wrapped up in. So the last type of curve here is a reverse curve. Is a segment of arc which the center of its circle is on the opposite side of the adjoining curve, and of which one of its radial lines is the prolongation of radial line of the opposite curve. Jump to the next page. He's got just a bunch of definitions. Another great example of how we could screw up curves in a description. Very complicated curve diagram. He's got a tangent curve. Tangent curves have a common radius point or prolongation of each other's radius, though they may be of different lengths. Therefore, compound curves and reverse curves are by definition tangent.
Which just means that when you're writing your legal description, you don't have to say a tangent compound curve or a tangent reverse curve.
Yep, absolutely. You know, and there's another thing is if you are doing design or working on lines that are near tangent, you know, it is important to call it out or recognize that maybe a line isn't a tangent curve or a curve isn't a tangent curve. You know, because it could be, you know, near tangent and could screw something up if all the information isn't there. I've definitely seen descriptions where they seem like tangent curves and not all the information was there and they ended up not being, you know, and could mess something up. So tangency, and I just explained this to a young drafter today, a tangency, a point of a curve to a line or curve that means the radius line is perpendicular to that line or the tangent of the curve at that point of curve. And if you go back to like basic algebra and math class or geometry, a tangent line only touches a curve or a circle or an arc once. That's it. So the only way to make that happen is it does need to be perpendicular to the radius or to the bearing to the center of the arc. concavity and convexity. So concavity relates to the enclosed side of a curve toward the center of the circle. The general direction given for the concavity is that the radial line from the midpoint of the arc toward the center. And convexity, seldom used, relates to the outside face of the curve away from the center. So that figure 30 shows you that that arc is concave to the northwest for the whole curve. So the way it was explained to me is it's the cave. The cave is open to the northwest as your kind of your simple thought process for that. And again, this is one of those things is I don't encourage people to write it. I don't see it written all that much, but remembering what concave is and how to define that, people get mixed up in that a lot because I guess we don't use it enough out here, and so that's always a difficult one. So David, you said you guys still use that and write that pretty often there in California?
Yeah, about the only thing we see.
Okay. So do you call like an arc to the left or an arc to the right
No,
with that too, or just the concave direction?
no, it's concave one way or the other. Yep.
Okay.
And we did it in Minnesota too on the report 4 that they came out with, and I'm sure Jerry would agree. But they used to do concave to the south and tell you it's on a radius curve, concave to the south, or whatever direction you were heading,
Right.
or thence easterly along a tangential curve. They never assumed. They always told you if it was tangential or non-tangential, just to take out the guesswork. But I see out here in California, I see nobody. So you have, unless it's written non-tangential, it's always tangent.
Right.
Yep. Okay. Yeah,
Can I ask,
go ahead.
can I ask a question?
Yeah.
Being that I'm looking at the I'm pointing to the screen like you can see. Yeah, right where you're the curve, the 300 with a 400-foot radius length. Now, where do you put your because like you said earlier, our technology, my data collector that I just picked up and figured out that curve with, figures it out that the delta is another 19 seconds. So where do you put that when you don't have that delta information or something like that? And then you have 4 or 5, 6 curves, and then you come into the tangent, and then you're not coming in perfectly tangent or perfectly 90 to the tangent because you know how you have in the curves. So where do you end up putting that Just a question from,
Yeah, that's a good question. That might be, again, some of this is case dependent, right? That might be more difficult to kind of determine. But just looking at this example, if I were to recreate that and we're going from left to right as we read that, so you're going north 50 degrees east, that 726, and then you hit the beginning of the curve. And so again, like in a CAD sense or a data collector sense, I would take a 90 to that bearing, that first bearing, and go out 400 feet to the point of curvature. And then
this is where my problem is. I come out 90 degrees, but now I don't have the delta. I have my data collector because all I have is the length and radius and then curves to the right, because that's how RDs read out here. Now I have, because my data collector is right here in my hand, it's 4258.19 if it's a perfect 300. So now I've already got 20 seconds of in that first curve. Now coming around, I didn't figure out the rest to figure out what it is going to come into the tangent. But now, there's at least you're going to build up now, not knowing that if I don't have that delta in the deed, I'm going to have out in the field when I'm setting it up.
And I think it goes back to the precision that it's of the numbers, right? So it's like here, he's giving you 4258, and I think going back to like Joey and David's thing, at this point, these are probably your stronger numbers, being 400-foot radius and 300-foot length. This is only to the nearest minute, and then they don't provide a delta on the next one. They only provide whole numbers again.
Gotcha.
And so I just think it's based on
Then
that
what I
era,
should,
on the era that it was written.
Right.
That
You
is the
don't have,
mathematics. Yeah.
right. That's
Yeah.
exactly it.
Yeah.
It was created this way.
Yep.
Because they knew there was going to be error.
Yeah.
And you
I
could, and
gotcha.
at the time,
Yep.
they couldn't make it any more exact.
Mhm.
So this goes back to significant figures.
Yep.
And by
Yeah, so
significant
I
figures-
guess what I gotta do when I'm in the field and I see a 300 or something to the nearest foot, I need to dumb down my
Yep.
my data collector from the precision so I can work out the numbers back to the original.
Yeah, because even the
And-
starting bearing,
Right.
right? They went to the nearest degree, and so
Yeah,
it like David says, it's significant numbers, and so you're dealing with error already because this is to the nearest degree, and this is to the nearest minute. Or at least these are whole numbers by being full foots, but maybe it would be a different story if this said 300.10, then maybe, or 299.9, right? Then maybe you're closer to the minute mark. But because everything is based on full whole numbers, that's your error.
no, absolutely.
You got foot error
to-
to the even foot error.
Yeah, I totally agree with you. It's just that I'm working with a AutoCAD or a data
Yeah.
collector that
Yeah.
can round the numbers all the way. So I'm like, yes, I got to get it that precise,
Yeah.
and then realize I'm at the tangent. I'm like, well, I got myself some error. So now
Yeah,
it
this-
makes total sense that I need to dumb down the precision to get the original delta.
Yeah. You could be,
Right.
like you said, this is probably a plus or minus by the time you get over here to the point of cusp, right? That could be a 5 or 10 foot radius of
Yeah.
error, really, right? So,
Yeah.
Yeah.
And it gets double hard when you're working, let's say in AutoCAD, and you're working in parcels and it needs to close, or you've
Yeah.
got a description that the county wants to close. And so there is other things in there in this discussion that kind of happens is maybe you do, for the field procedures, you dumb it down for a little bit and you find whatever evidence you can. But as you write a description or rewrite a description or show it on a record of survey, you can show where, hey, look, I've calculated this out, but I can't get this to close with these ones. So here's where I've placed my error. Record is 4258, measured is 4258.19 or whatever you were saying you were getting, right? And so you can show and explain how you got it to close or where you placed error in there for the next person to follow. Certainly a narrative helps in that. We talked a lot about that in the last book, is just explaining that. Went out there and I couldn't get it to close. These, here's my significant digit. So I went through this process to find it. Or maybe you're out there in the field and, you do hold the 4258 and you hit a barn cap perfectly. Or on the other side, you don't. You miss the barn cap, but the barn cap fits your calculated 4258.19, and so there's some evidence in there to start evaluating, and that's what gets into the PLS side, is that evaluation of evidence. You start at face level with whatever you have, and then work backwards or forward from there and defend yourself in any decisions that are made. And in that case, there may not be a right or wrong decision. You could throw the error in any one of those three based off of the evidence you find, and if you can defend that in a written narrative, I don't think anyone's going to hold that against you, because you've explained how you got to where you did.
Now they're not going to go against you just because it's your opinion. What is your opinion of your analysis? And you're exactly right, Trent. That's how we get into the analysis of being a professional surveyor and coming up with an opinion on what do we do in this situation based on the evidence that we found. Yep.
Absolutely. And that's the hardest part. That's the hardest part for young new surveyors to feel confident in doing, is at some point you just got to pull the trigger and make an evaluation and defend it. And that's the hardest part. And it's the thing we can't really teach. We can talk through all these processes, but it's the hardest thing to really teach someone how to do. But I think that's a great question.
Awesome. Thank you. Yeah, what I usually end up doing is running the deed backwards and then seeing where the error is, if it isn't a non-radial one of the deeds I showed you earlier, and figure it out that way. So there's
Well,
plenty of ways to skin a cat.
That's what I do too, is I generally try and run it backwards too to see if I can identify anything. So great.
I
Thank you.
would approach this little case right here that we're talking about with maybe a little bit different manner. There is probably a starting point on this right of way where maybe it's a straight or maybe it's a curve, but there is a starting point on the track where it first gets to this geometry that's laid out here. And there is an ending point where the track leaves that area. And if I could identify those places, those two places on the ground, and if there were not any monuments set along the right of way that I had needed to yield to, then I would run the exact geometry that's shown on whatever document this was based on. I would run that hard geometry. And then I would take it and I would rotate it to fit the points that I knew it had to fit on the ground for the track at the start and the end. And whatever rotation, which probably shouldn't be very much, is done. And then I would apply a scale factor to make those two ends match exactly. And that way, all of the terms that are in the curve data would match what I have on my plat very closely, probably, because I would expect there would be very little scale factor needed to fit that. And I would be giving effect to every term that's in the deed. So that would be my way of solving it.
Absolutely. Yeah, part of that evaluation of evidence. Thanks, James. A couple other, we've kind of hit these terms here real fast. We'll get through this. Non-tangent, again, we've kind of talked what tangent is. So non-tangent being the opposite. A cusp, that was kind of a newer one for me. I don't necessarily see two curves or 2 points kind of aligned kind of like that, but a cusp is the meeting of two curves or a curve and a straight line having the same general direction. The point of a crescent moon is a cusp.
We use that a lot.
Okay. And then the direction along the curve is called out generally northeasterly, southeasterly, westerly, whatever it might be. And then he kind of gives a caveat there. If it's more than 120 degrees, two directions could be called out. And I'm not sure how I've seen those done around here. So I'd have to think about that one if we have any local traditions for that. And then we've got just some common abbreviations for curve. So BC, beginning of curve. PC is a point of curve, point of curvature. BCC is the beginning of compound curve, or PCC, beginning of reverse curve, BRC or PRC. The one we see here pretty often is PT, point of tangency. So you've got PCPT, point of curvature and point of tangency, where you leave the curve. Midpoint of a curve is halfway along the arc, and the point of intersection, PI, is a point at which the prolongation of tangents of a curve passing through each other intersect. And I think the first figure actually had a better, figure 28 had the better kind of example of what a PI is, just for clarity's sake there. You've got your two tangent lines that turn into the arc, but if you were to extend those two straight lines to the 90, that's your PI where they meet. If you get into geometry math, there's a lot of in non-tangent curves or different things, or even tangent curves, but you've got where it says PI right there, the deflection of angle here, the central angle. There's a lot, there's some other figures out there in your old high school math books that opposite angles are equal, right? And then you can even calculate out, if you were to create a complete square and cross intersection there at that PI, the east and the west, if you will, would be the same angle. The north and the south would be the same angle. And so you can actually do quite a bit of math there. If you don't have all the information or have some of the other information, you can mathematically extract out quite a bit. And we won't get into math class here, but those that were good at it can remember some of those formulas, geometry formulas for pulling out angles out of figures. So there's some abbreviations. Is there any other local abbreviations you guys use that aren't listed here?
Are we allowed to use any outside of this book?
No, Wattles is the truth, right? That's all we've got. So, next page, he's got EC, end of curve, center circle. And then I highlighted this right here before this figure 32. It says, before proceeding with multiple curve calls and curve description writing, let us consider the problems involved by the use of the words right or left. And this is the way I like it. So, we disagree here. The use of words right or left to connote one side or the other is not fully satisfactory. In the early days, the courses or rivers would be described as following the left or right bank going downstream. Attempts were made to adapt this to other uses, but inherent variables made it uncertain. See figure 32. A compass direction or a positive bearing is much to be preferred. And so he gives like that D, right and left, because you're turning, or at figure B, C and B, make those right or left determinations a little bit more difficult to make. I guess I'm not dealing with courses or rivers and downstream calls enough to consider that, but there we go. I jumped over. Any other questions about kind of curves, part of the curves? He gives a lot of examples here, but I wanted to jump over to some other highlight areas. So on the next page, figure 33A and figure 33B.
Trent, Teresa has one in the
oh yeah, go ahead.
chat. She's got a spiral curve, BCT, begin, curve, taper.
Yep, they just saw this week on a old railroad map that we're dealing with in Tulare County, and so this is begin, curve, taper, compound curve, taper. It looks like.
Holy moly.
I don't know what. Yeah, CCT is something I've never seen. I know that begin, curve, taper, and then what's the other one? It has to be something to deal with a spiral curve.
Interesting.
Yeah, I just saw that this week. I get bonus points at work if anybody can figure out this curve. I'm like, yeah, no, not enough brain power left in my tank to do that this week to get bonus point. But it's an interesting curve because it is a spiral curve. So you have to go into the taper and then go hit where the CCT is to the other CCT and then taper it again.
So are they providing any other information? This is all we've
Nope,
got
this
here.
is it.
it.
With that TC, see that curve taper. They give the total curve itself. The angle is 28,918. I'm missing that part of it on my little snippet here, but that's it.
Wow.
Crazy, huh?
I wish I could remember back 70 years ago and what my father was telling me about those railroad curves and whatnot, because I'm a second generation surveyor. My father was born in 1899 and he went to work 100 years ago this month with a mining company, and his boss, who taught him surveying in this engineering department, had cut his teeth building railroads around the turn of the century. And so my father was very skilled at laying out railroad spurs, but I just really was too young to really pick it up. I wished I had, but I hadn't. And I'm sure that probably what you're looking at there, if you could get one of those old timers who was still alive, he could explain it to you very perfectly that everything that you need is probably there.
Exactly.
but I can't help you.
Exactly.
Yeah, the one thing that pops out to me is the after the BCT, there's a 3-point there. It says 3 dot with no explanation, but the second line says 30 feet right. I'm guessing there's got to be some other construction map that goes along with that probably clarifies some of that. They were calls out the actual center line of track with some other clarifying calls, and this is my guess is some sort of supplementary map. In my experience, there's usually a couple different. There's a construction map and a right-of-way map or a route map, and you kind of have to combine both to get all your information.
Excellent.
What was it for? Right away of some sort, or like
It's
irrigation?
a railroad. It's
Oh,
a
it's a railroad.
railroad through their property, and they're
Okay.
trying to figure out what the curve is. So
Okay.
we're doing that old PIQ is the property in question. So you're
Right.
trying to figure out what they own along this curve.
Yep.
Yeah.
I know. Didn't Connie have some stuff about? We talked maybe on evidence or something. She had talked about some local Southern California stuff when it came to railroad stuff, but maybe we can.
Connie would probably have something on
I thought so.
on that. So yeah.
Okay, cool.
Yeah,
I'll
yeah.
touch base with her.
Yeah.
Okay. Yeah, I remember her talking about some stuff on some of these, about some SoCal railroad stuff that they had come across over the years. So.
Okay. Well, great. Glad we can get some resources for you. Hopefully, you can get your the prize from work for figuring this one out here, from attending here. It'll be all worth it.
That's right.
Thank
So
you.
jumping back into the book here. So Trent, I'm jumping down to figure 33A, 33B on 427. So the next page down. So he kind of gives some more examples here. 2 or more curves having the same radius but not common center points, whether in one or more planes, are considered to be equal but not concentric or parallel. Figure 34, although corresponding points are at equal distances along parallel lines, the curves are still not accepted as parallel. So just some interesting ways to view curves and have them written, and just make sure that you're doing whatever evaluation you need to understand what they intended to write or display there. So. And then on 429, he gives another really good example of possible alternatives with multiple fixed curve calls. So he says, in this case, if the line after the curve must be parallel, then only one condition of the curve should be given, whether one is to control, i.e. radius, length, angle, or chord, with no mention of its being tangent to said parallel line. However, this would probably result in a broken back type of relationship between the curve and the following line. Otherwise, if the line at the end of the curve is to be tangent regardless of parallelism, then give 2 conditions of the curve and make no requirement that the line be parallel or at any given distance from the right-of-way. If all 3 conditions in relation to the right-of-way must prevail, then the description must be written with variables to permit the length of the line or curve preceding the last curve to give in such a way that the last curve can be adapted to fit in the combinations. So we have a right-of-way here, 4150 feet offset. So first one is parallel 4150 from right-of-way, but not on radius, delta, or length sighted. The other curve is parallel on radius sighted, but not 4150 from right-of-way. Parallel at given curve length with a broken back and not 4150 from right-of-way. Broken back being non-tangent. He kind of mentioned that in that non-tangent one, but just make sure we clarify that. And then tangent with given radius, delta length, but not parallel with right-of-way. So some interesting ways that curves can be described or misinterpreted in there.
That goes back to some Joe's comment about the although I mean this one they have the even foot on the radius, the length is to the 100.
Yeah.
The delta is to the seconds. Like it's crazy the amount of error you're still gonna get.
Yeah, absolutely. Cairo, when describing a concentric curve, should they be concentric with or concentric to the other curve?
I asked because Wattles is specific about using parallel with and not parallel to, but he doesn't even mention this. And I'm like 3/4 of the way through this question I'm writing, and if he would have just been clear about this, I'd be done already.
That's awesome.
Yeah, I'm not quite sure what he'd lean to there. That's a good question.
Yeah. Oh my gosh.
Okay, so let's see, we are at 6:20 here, my time.
Yeah.
So good, we've got time. Here's the question everyone keeps asking here on 4:30, rehabilitation of curves. And I apologize, I'm reading a lot out of this, but I think just kind of going through what he says is better than me trying to summarize some of this. But let's just read out of here and we can go through some of these examples. In determining which element should be held in describing or rehabilitating a curve, when a field resurvey reports conflicting facts, one needs to know how curves are created in the field location of the center line of a road, either an existing one or a new one to be established. The general procedure is to locate the middle of the straight sectors and prolong their tangent lines to intersect and set those points of intersection for control. The deflection angle at the PI is then measured, although sometimes the angular measurement is set first at an even figure and the tangent line is moved to conform. If ground conditions are unacceptable for setting a point, as perhaps it might be at PI number 15 in the illustration, either the radius to the center of the circle of which the arc will be tangent to the tangents will be set off and measured, or the chord will be established and measured for the length and deflection angle. Of course, the deflections from the chord to both tangents must be equal. After the deflection angle at the PI is measured, which by geometry equals the center angle, usually either the radius is assumed at an even number of feet or the semi-tangent is set at an even number of feet. In either case, the control is established and the remainder elements are calculated from them. So that gives us some direction to answer those questions is the big what ifs. And so what I'm gathering from this is you're actually taking the tangents and extending those out and then working back from your PI there to figure out a best fit in all those. So you might not be holding the radius or the deflection angle, creating those tangent lines being probably the more critical method that he's explaining in here. Any thoughts, confusions on there? Does that all make sense? That was a mouthful to read because we're tangent to the tangents. And so he gives some calculations on the next page of looking through some of this. And he even gives an example. I mean, I guess I'm just going to keep reading here. It is because of the fact that two of these three elements, the central angle, semi-tangent, or radius, are determined in the field to be the controls for the curve that you look to them first in the event of any discrepancies. So on the next page, if, for example, the curve data is shown on the map as the following, it is obvious that the creator set the angle and assigned the even foot radius. If the field notes of a resurvey of this curve show this, and so we've got this example of how to kind of work through those. He shows the found original 2x2, found original 2x2, and found original 2x2 in the tangent lines. And you can start calculating out those angles and then calculate the radius from the tangent. Certainly don't want to get into a math class here, but want to make sure there's no questions on this. If we need to spend some more time discussing it. And this might be more difficult, from the question on that compound curve figure a few pages ago, because you don't really have you're going from a tangent line to a curve to a reverse curve to a compound curve, and then to a line. So you'd have to kind of, at least in that example, work through a couple different cases of maybe the chord there. What is a tangent distance coming out of through the PRC there, to try and figure out where your PI is and some of that other stuff, depending on the field conditions. Some interesting stuff to think about. So there's no other questions on that. We'll jump into, just real fast here, finish out curve format. And I think that gives us to a pretty good spot. But the following description is for the purpose of giving you a format to use in wording of various types of curves. It says that portion of lot 6 in Northwoods Tract, city of, as per map, beginning at a point on the west line of said lot, southeast 198 feet along said line, and its prolongation from the center line of Northwoods Avenue, adjoining said lot on the north, thence southeast, along said lot line to the beginning of a curve, concave to the northeast, having a radius of 28 feet, thence southeasterly 4398 feet along said curve through a central angle of 90 degrees to the beginning of a compound curve. So that's his, in this example, at least a good example of how he would write a curve. So we're giving out the critical information first, the concave direction and the radius, and then we go through the curve as kind of almost a separate call, southeasterly 4398 feet along said curve through a central angle of 90 feet to the beginning of another curve. And so when I read this again, when we talked at the beginning of this book, I threw out the challenge there that description shouldn't be written in paragraph format as they are here. And so you would often see that in a kind of a 2-line type thing. And so you'd have your first line going, the qualifying calls there, the curve, and then the actual calls through the curve there. And he kind of does the same with the compound curve. So that's to a compound curve concave to the north, having a radius of 93 feet. Then it's easterly 50.69 feet along said curve to the beginning of a reverse curve, concave to the southwest, having a radius of 45 feet. Then he actually throws in the radial line for that. Radial line through said beginning of reverse curve bears, then it's easterly and southeasterly 88.77 feet along said curve through a central angle of 113 degrees. So he's thrown a lot of different examples of, right there all together real fast. So I guess David, that's how you guys see them more generally written out there with the concave and that kind of format.
Yes, this is exactly how we see them on a regular basis.
Okay. Our general way we see them here is to a point of curvature, and then thence, let's say easterly, along the arc of a 50-foot radius curve to the right, and then in parentheses we'll give all the information. Said curve having a delta of the center bears this direction through a chord bearing of and that type of stuff in parentheses secondary to that. That's a pretty general Utah way of writing things. I'll bring an example next time. I'll have one prepared when we start the discussion next time, just so we can kind of see a different way of writing it. But there we go. There is a whole lot on curves and still a whole lot left in this chapter here. So
do you want a part 3?
What's that?
Are we going to do it as a part 3? Okay.
I think there's enough. We'll get into chapter 5 for sure next time, but I think there's enough to go through. I think we'll go through it rather quickly, but there's still enough to go through in here and some great examples that it's worth kind of stopping at the half-hour mark here and taking a break. So any other questions about curves, what we've gone through? Certainly a lot of math class here, a lot to consider. So a lot of what ifs.
all good stuff.
Yeah.
Everything you see every day. So
if you want some more good stuff, let me throw the plug out here. Tomorrow is the UCLS has their field forum. We have got a great lineup of guys. I'm even presenting on staking procedures. So if you haven't had enough of me, sign up for it there. We're going to go through just some standards and procedures, some classes given at UCLS a few years ago, some stuff there. We've got some level procedures in the field. We've got a guy talking about scanning procedures, proper methods for getting control and set up on that. And then when we started this, I had just interviewed on a podcast about a unique land situation in Western Utah where some land was sold on eBay. A guy with iHeartMedia is doing a podcast on that. So they're actually going to be our capping speaker there. And we're going to talk about what they've learned, some of the experiences they've had, and kind of get a landowner's perspective on what survey is. And it should be just kind of a good discussion. Again, this is kind of geared towards our up and coming PLSs, our crew chiefs, our young rodmans that want to start moving through. And so hopefully get their minds thinking about what it is to determine property and make a survey. So should be pretty good.
What time is it? 8 o'clock your time?
8 to 1 Mountain.
Yep.
It's on Zoom. So
Yep.
jump on ucls.org to register. The money goes to our foundation. It's $30. And those that register, and I know that's a concern for some businesses where it's busy right now before winter hits, at least in Utah. So those that register will get a copy of the video as well. So that's what my company is going to do is we've registered, and then on a snow day, we can have, we'll pull it up and have our guys watch it when it's kind of hard to get out to the field.
Perfect.
At the end of this chapter, there were some questions pointed toward a particular lot subdivision of several tracts that were cut out of a single lot. And it was a very interesting little example, I thought. And it stopped only one tiny little bit short of something that a lot of surveyors will stumble over to their detriment if they're ever in court. And I wish that we'd had time to get to that point tonight.
We'll make sure to hit it next time for sure. So remember it, mark it down on your book, and we'll bring that up next time so we can discuss it in depth.
There it is, shown on that on the screen now is lot 17. I would encourage people who are surveyors or want to be surveyors to take a close look at that. There's some principles involved in there. One being, I guess, what surveyors would call seniority of deeds. And that'll take you a long way, but there's a little more to it than that. And I really encourage people to look at that.
Okay, we'll do that. We'll be ready to talk about that next time.
Okay, I hope I can make it.
The 29th. We'll be back on the 29th.
29th.
Yep. I threw Trent's field forum sign up in the chat if you guys want to grab on, click on that. Like he says, you don't necessarily have to watch it live. You can watch it later. So
yeah.
Obviously you lose out on the Q&A part of it, but at least you can always watch it. So
yeah, absolutely. Thanks, guys. Have a great Thanksgiving.
Awesome.
See you in a couple weeks.
Bye, everybody.
Thank you very much. Bye.
Have a good night. Bye, guys.